All right, apologies for the lateness. I just had a meeting that finished, so I couldn't even dip out because I was trapped there. All right. So that's over. Well, wait, I want to see two people. Well, after what happened to the rest of you? Okay. And I'm rushing to get to you, and there's nobody here. All right, you know what? I'm just gonna go and do my thing. So let me see what was the last thing we were doing now. I think we're supposed to start the skin if I remember correctly. Yeah, let me know if I'm wrong. All right, your skin.
Yes, sir. It is so remind me about um the
Of
the
course.
last inquest test.
Didn't I send you the thing in Moodle?
Say Moodle down.
No man, it's back up. I got an email about it. It should be back up.
You sent us on. So you said you sent it to us on Moodle.
Yeah, man, it should be there on Moodle. I mean, I put it up before it went down, but I got an email. I think it was last night indicating that Moodle is back up.
Oh, wait, they did tell us we have to download Firefox, but wait, is the answer that you sent to us or our grade?
The answer sheet.
You don't have our grades.
All right, I need. All right, let's do it after class though, because we will have a lot of time. I'll see if I can. Everybody has sent me an email, so I'll go into my email and respond to you by email later.
Okay, sir, no problem.
But the answer sheet is on Moodle. All right, skin. Your well, let's not say skin. Let's say integumentary system, because it is more than just the skin. Okay, the integumentary system is what you would normally refer to as the skin, plus the hair and nails, as well as all the other organs, well, and glands associated with the skin. Okay. Now, there are some of the functions, or let's say factors that can affect your skin. One, of course, is nutrition. Diets low in vitamin E, you will tend to find your skin, vitamin A as well, will tend to be dry, flaky, cracks easily, for as an example, right? Hygiene. Um, Hygiene is an interesting one because yes, you need to keep your skin clean, absolutely, to help to control bacteria. But there is actually evidence that excessive bathing with soap can actually harm your skin, which sounds counterintuitive. But it's actually you have some people who will bathe 3, 4 times a day, which of course is excessive, right? And every time you bathe with soap, you're washing away your body's normal or skin oils. And that leaves your skin open to microorganisms coming in. So if you're one of those people who needs to bathe excessively, it's a good idea not to use soap every single time. If you're bathing 4 or 5 times a day, right?
So screen sharing?
It's not?
No, sir.
Let me check. I thought it was. What's going on with this thing? How about now? Yes? Okay.
Yes,
Now,
sir.
you still can't see it?
I see it, sir. I see it.
Okay. Circulation, of course, is important as well. Blood flow to your skin is needed, of course, because your blood will carry cells of the immune system, right? It also helps with nutrients for the skin as well. Now, the older you get, the less functional your skin becomes. And that's why as you get older, your skin tends to get drier and thinner and loses elasticity and all sorts of things, right? Now, sunlight. The exposure of your skin to sunlight is not something that the average Jamaican person worries about too much, right? But even people of a darker persuasion can still get sun damage. If you've ever been out in the sun for an extended period of time and you're finding yourself getting sunburned, then of course you fall into this category, right? Now, your skin can also respond to your psychological state. You know, anger and sadness. If your skin is lighter, you can see changes to blood flow on your skin, like blushes and things like that, which can show people, you know, how you feel. Then, of course, microorganisms we mentioned before. Your skin is not, generally speaking, a good place for bacteria to set up shop. But of course, if your skin is not well cared for, you can, of course, get infections. So, for example, ringworm is an infection of the skin, right? And environmental pollution. The more your skin is exposed to pollutants, the more damage can be done to your skin. Particularly for people who swim in water, it is not the best. For example, I don't know if you all know this, but you have a lot of people who swim happily in Kingston Harbor regularly as if it's the most natural thing in the world. Even though Kingston Harbor is extremely polluted, right? If you drive past Kingston Harbor and the breeze changes, you can smell the eutrophication in Kingston Harbor, right? But people are swimming there all the while, right? And of course, get skin problems all the while as well. Now, drugs and alcohol abuse is an interesting one. Because some drugs, like crystal meth, if you know that one, can actually lead to skin damage over time. There's even this drug there, they call it a zombie drug, it's a new one. A zombie drug. It actually causes sores to break out and causes your skin to actually slough off in places. Right? Just like you said, a zombie. And people are addicted to it like hell. We won't get into that. Now, let's talk about the general structure of your skin. Your skin has two main layers. The hypodermis is sort of a secondary layer, right? In some books, they just say 2 layers alone, okay? But I still do like to mention hypodermis as well. You have the epidermis, of course, which, as you know, epidermal is the outermost layer of something. It is made up primarily of keratinized stratified squamous cells, right? Then, but they have several layers of different cells as well, we should talk about. Then you have the dermis, which is, of course, below the epidermis. And it is a more functional layer of the skin. It contains dense irregular connective tissue. This is where you'll find glands and hair and all of these things as well, right? The hypodermis is mainly going to be adipose tissue and areolar tissue, right? So fat, well, basically, as you know, those are 2 types of light connective tissue, right? Now, here are the basic functions of the skin, right? Thermoregulation, protection, sensation, excretion, immunity, and of course, helps with vitamin D synthesis. So, thermoregulation. As you all know, your skin contains many capillaries. Capillaries can bring blood to the skin. That blood can release heat through the skin into the atmosphere. And by doing that, you basically cool your body, right? So releasing the heat cools your body. Of course, you can also sweat through your skin, which can also cool your body, right? Now, if you move blood deeper down into your body, as you know, you keep the blood away from the surface of your skin, which means that you keep more heat in your body. So if you're too cold, you move blood away from the skin. If you're too hot, you move blood towards the skin. Then now we have protection. Your skin is a physical, chemical, and biological barrier. By that I mean, if something drops on you, as long as it's not too heavy or too jagged, it tends not to tear through you, right? You bounce into things all the while. You don't normally get torn open, right? So it's a physical barrier. Chemical barrier, I'm sure you've had bleach or salt water, these things on your body in the past. None of them have caused you any damage because your skin is resistant to these chemicals. And of course, the biological barrier. Basically, your skin is proof against virtually all microorganisms. It is extremely difficult for microorganisms to make their way through your skin and into your body proper. Very, very difficult. I think I've mentioned to you already that, hey, HIV can splash on you. Right? Blood contaminated with HIV or any other the normal disease you can think of can splash on you, and you're perfectly fine. Because that blood will not pass through to get to your into your cells beneath your skin. Right? Then now, sensations. Oh, sorry. It also mentions here tight junctions. This is the reason why substances, sorry. Apologies, I just went through anyway, I'm probably getting a cold. Because you're how tightly packed your skin cells are, it's extremely difficult for pathogens, as we mentioned, even viruses like HIV, to squeeze between the cells to get into your body proper. So those are the tight junctions they're referring to, like how tightly packed the skin cells are. It also mentions here that the oils in your skin, lipids released, will reduce evaporation from your skin as well. And of course, as we know, we have pigments in our skin like melanin, which help to protect us against UV radiation. And in the deeper layers of your skin, you have cells associated with the immune system called Langerhans cells. So if you get a little cut or something, or the odd bacteria does manage to squeeze its way through, these Langerhans cells are there to help control them, right? Now, sensation. Think of all of the interaction you have with the environment using your skin, right? You touch things with your skin. Things touch you, right? You can feel changes in temperature and pressure and something pinch you, pain, all of these things. Even vibrations, you can all pick them up through your skin. That's cutaneous sensations, right? Now, obviously, your skin is not designed to do a lot of absorption, right? As it says here, only a minor role is played by the skin in excretion and absorption. That said, you lose a lot of water through your skin. So only a minor role is played, yes, but 400 mils of water evaporates from your skin on a daily basis. 400 mils, that's about the size of a soda, right? And when I say evaporate, I don't mean sweat. I mean, that's just the water that turns into water vapor and leaves your body on a daily basis. Sweat, of course, is extra. But as you're sweating, small amounts of salt, carbon dioxide, ammonia, and urea are all excreted along with the sweat. So these things are actually being removed from the body. And of course, ammonia and urea are metabolic waste. So hence, this is excretion, right? Now, that said, some lipid-soluble substances can pass through your skin. As good as of a barrier as the skin is, if substances can dissolve in lipids or react with lipids, they have a tendency to also be able to pass through your skin, right? Now, sometimes it's good because there are some vitamins that you can absorb through your skin. So vitamin A, D, E, and K can all be absorbed through your skin. So that's why you sometimes find like lotions and these kind of things that will have these vitamins in the lotion. It actually does help, right? I mean, don't expect miracles, but you can slowly absorb these substances from the lotion. But I'm going to be perfectly honest with you. For it to be of any great significance, the amount of lotion your skin will have to absorb, it's highly unlikely it's going to happen, right? So still take your vitamins, right? The lotion can't substitute for good nutrition, right? Now, it also mentions that a small amount of oxygen and carbon dioxide can also pass through the skin. Remember, this is a very small amount. Not enough to make any real difference to you, right? Also, chemicals like acetone, which once again, fat soluble or can dissolve fat, can pass through your skin. And acetone is poisonous, right? Most of you would come into contact with acetone in the form of nail polish remover, right? There's a reason why when women are using nail polish remover, they're not supposed to get their fingers in it. Because the acetone will be absorbed right through their skin and poison their cells. Obviously, I assume the average female isn't sticking her fingers down into the nail polish remover bottle and holding it there. But yeah, if you're a cosmetologist or one of these people who are constantly using this stuff, you can actually poison yourself with it, right? It also mentions dry cleaning fluid, but chance of you coming into contact with it is very low. But lead, right? Lead can pass through your skin. That's not good. Mercury, arsenic, right? So you have to be very careful with some of these substances, right? Now, first of all, let me state this about synthesis of vitamin D. Your skin does not make vitamin D. What your skin does is it energizes what you can think of it as pro-vitamin D molecules. Calciferol. All right. And then once you have energized with UV radiation, your proto-vitamin D or your precursor to vitamin D, that chemical then passes to your liver. And then your liver then finishes the process of making vitamin D. So please do not write that your skin makes vitamin D. You will get 0 for it. It's one of these stupid things that they tell people at CSEC level that make no sense. Your skin cannot make vitamin D. Your skin cannot absorb vitamin D from the sun. That is all nonsense, right? Then no. It mentions here, now we're going to talk about the epidermis of the skin. I mentioned to you earlier the epidermis, of course, is the outer layer of the skin, as you know. But the outer layer of the skin can be broken up into well, there are 4 types of cells that you'll find within the epidermis. And they, of course, arrange them in layers, but we'll talk about the layers in a minute. You must remember these cells. You must remember what they do. You must remember which layers of the epidermis you're going to find them in, okay? So your keratinocytes, for example, they produce keratin. Thankfully, it's in the name. So your keratinocytes make keratin. And as I'm sure you know, keratin is that protein found in hair and fingernails, as well as the upper layers of the skin, that's tough and resistant to abrasion. Okay? It mentions here that keratinocytes experience keratinization, a process by which cells formed in the basal layers are pushed to the surface and accumulate keratin. So as the skin cells go closer and closer to the surface of the skin, they absorb more and more keratin. Right? So they become more keratinized the closer they get to the surface of your skin. And keratin is important because it helps to make your skin waterproof. All right? Then now you have melanocytes. And melanocytes make melanin. Once again, it tells you what it does. So a melanocyte makes melanin. Keratinocyte takes keratin, right? And as I'm sure most people know, melanin is the primary coloring of the skin, right? Now, the reason why melanin is coloring your skin is because it's trying to protect you from UV radiation, okay? Now, a lot of people believe that somehow the earth is like the perfect place for the production of for human life to exist. It's perfect for human life. And no, earth is not perfect for human life. Humans have had to adapt to the planet, right? The planet didn't adapt to us. One of the things that we had to do was, as our ancestors lost the covering of hair that would have protected them from the sun, our skins would have had to have taken up the melanin that would have been in the hairs that would have made the hairs dark, and that of course would color our skin, right? So as human beings, well, not humans, or as our ancestors started losing body hair, then we had to start producing melanocytes for the purpose of coloring our skin to protect it against UV radiation. Why? Because UV radiation is extremely damaging. I'm sure you all know, it damages DNA to the extreme. It breaks DNA into pieces and can lead to cancer, right? So you need the melanin essentially to prevent you from getting cancer, right? Then now we have Merkel cells. Now, of course, this one's name doesn't really tell you what it does, but you can remember this one. Merkel cells are touch sensors. So when something touches against your skin, the Merkel cells are what allows you to feel that touch. Then now we have our Langerhans cells, which I mentioned earlier. Please remember, they're involved in your immune response. They're immune system cells. And note that even though they're involved in your immune system, they are still very susceptible to damage by UV radiation. So therefore, if you have very little melanin in your skin and you're exposed to the sun a lot, not only are you getting damage from the UV radiation, you're also damaging the immune system in your skin as well, which reduces your ability to respond to cancer if you actually do get it. So if you're of a lighter skin persuasion, you must be more careful with the sun because of this, right? I'm not saying that darker skin people can't get skin cancer, obviously. But obviously it is also more common in lighter skin people, right? Because of course, less melanin, more UV gets through. All right. So those are the 4 types of cells that you're going to find in your epidermis. Now, in terms of the layers of your epidermis now, here's what you're going to get. There are 5 major layers to your skin. You have the stratum basale or basal, Some people say basale, some say basal, it doesn't matter. You're writing it, so who cares, right? You have a stratum spinosum, stratum granulosum, stratum lucidum, and stratum corneum. Obviously, you must know all five. You need to know where in this epidermis they're located. You need to know how many layers of cells make them up. You need to know what their function is or functions are, right? The stratum basal is obviously at the base, hence it is basal. So it is the lowest level of your skin, of your epidermis, right? It is made up of cuboidal and columnar cells that are constantly replicating, and they contain melanocytes and Merkel cells, okay? So the stratum basal, lowest level of the epidermis, contains melanocytes, Merkel cells. So this is where the melanin comes from, and this is where your touch receptors are coming from, okay? Then you have your stratum spinosum. Now, this one here, maybe the word can help you. So basal, of course, is the base, which is the lowest level. Spino here is referring to spiny. The idea here is that the cells of the stratum spinosum, when you look at them under the microscope, they're angular, they look like they have points. Hence, they're called spinosum, as in spines, right? So they're spiny cells. You have around 10 rows of these cells, and they contain lots of melanin. So the melanocytes below them make the melanin and then pass the melanin to the cells of the spinosum, okay? Then now we have the stratum granulosum. And once again, hopefully, the name for this one gives you a clue. Granulo means granular, as in grains in them, right? So the stratum granulosum has cells that look granular. They have lots of little grains in them, right? So they have dark stained granules. They have about 5 rows of these cells, okay? Then now you have this interesting one here. It's interesting because it is not always it's not in all parts of the skin, okay? The stratum lucidum is found only on the palms, soles of the feet, right? And when I say palms, I'm also referring to the anterior of your digits as well, right? Now, this layer of cells is actually a thick layer of clear cells, right? They are flat cells and they are dead, right? Now, if you've ever done this as a child where you took a pin or a needle or something and shoved through the skin on your palm and you could see the needle through it, you stuck the needle through your stratum lucidum, okay? Remember, please, only found in the palms and the sole of the feet. In these areas, we call that thick skin, okay? And the stratum lucidum helps to make it thick. Remember, 5 rows. Then the last one now is your... Oh, by the way, I should point out that the word lucid means clear. So, for example, I don't know if you ever heard of somebody having a lucid dream. A lucid dream is a dream that is so clear to them that they have a hard time distinguishing it from reality. You know, occasionally people have these dreams. I think pretty much everybody will have 1 or 2 in their life, right? That said, lucid dreams are not super common. Now, the last layer is stratum corneum. Now, I'm hoping the corn part of this will help you to remember this one. I'm assuming everybody has had a corn or seen a corn on someone else's foot. What is a corn? It's a thickened area of rougher skin, right? And the part of the skin that is thickening is the stratum corneum. So stratum corneum is the uppermost layer of your skin cells, and that is the part that gives you the corns. Now, if you notice, you have 30 rows, so it's the most by far, of flat, dead cells. Now, why do we have all of these dead cells? Why do we need dead cells in the first place? The dead cells are important because if the cells are dead and waterproof, they can't be infected by anything. That's one of the reasons why your skin is so good at preventing infection. Once your skin is intact, viruses and bacteria can't infect it, right? Now, this is, of course, a little diagram of your epidermis. I'm just going to point here. This is your stratum spinosum. So as you can see, kind of sharp points at the corners. So it's kind of spiny looking, hence stratum spinosum. The stratum basal, lowermost level, right? So remember, one layer of that, 3 layers of the spinosum. Then you have the granular layer here. And of course, remember the granular layer has large granules in there. 3 to 5 rows of those. And then now on the palm, soles of the feet, you have a layer of stratum lucidum, which remember, transparent cells. And then sitting on top of that, you have your 30 layers of stratum corneum, right? All right. This, of course, is actual histological section of the skin itself, okay? Now, I should be able to give this to you and ask you to identify all of these layers, okay? I might just. So please make sure if you're given an actual section of the skin that you can actually label the thing, okay? All right. So that is the epidermis. Now, what about the dermis? Remember I said to you that the dermis is a more functional part of the skin. There are more things going on in the dermis, okay? First of all, the dermis, remember, is made up of connective tissue. So the epidermis is made up of epidermal tissue. The dermis is made up of connective tissue. It contains a lot of collagen and elastic fibers, right? The collagen, of course, as you know, is a fiber that gives strength to a tissue. So it resists pulling and tugging, resists gravity. Whereas elastic fibers allow, of course, some amount of stretching, but it allows for recoil too. So things snap back to where they're supposed to be, all right? So the idea here is that the skin has structure from the collagen, but it can still has a certain amount of flexibility due to the elastic fiber, right? Now, one way you can see this elasticity is, of course, when a woman gets pregnant. When a woman gets pregnant, and of course, the fetus is growing, and as we say, the belly getting bigger, the skin stretches to accommodate this growing rotundness. All right? Same thing happens when you gain weight. Your skin stretches also to compensate. Now, here's the thing. If your skin stretches very quickly, right, you might find that you're swelling faster than your skin can compensate. And when that happens, the skin will tear and heal. And the tearing and the healing is what leads you to have stretch marks. So if you have stretch marks on your body, it means that that area of your skin got stretched too fast to compensate, and it simply tore and gave you these stretch marks, okay? So if you gain weight rapidly during pregnancy, or you just gain weight rapidly because you eat too much like myself, you end up with stretch marks. Now, a question I'm often asked is, hey, can you get rid of stretch marks? The answer is no. Stretch marks are scar tissue. They're not simply going to disappear, all right? They will fade over time and become less visible, but they're not going to simply disappear. Okay. Now, upper layers of the dermis consist of areolar tissue and dermal papilla. All right. Now, the dermal papilla are going to form ridges in the epidermis, and these ridges are what form your fingerprints. Okay. So your fingerprints are coming from the dermal papilla in your dermis. Okay. Now here's something interesting about fingerprints. The way your fingerprints look is for the most part random. Okay. How random is it? Twins. Identical twins will not have identical fingerprints. So if one twin commits a crime and the other one didn't, as long as there's a fingerprint, they can't tell the difference. Otherwise, you're pretty much stuck, right? So the randomness of the dermal papilla leads to your fingerprints, all right? We'll talk about why fingerprints are important later. Now, we also have mentioned in the dermis, you're going to have dense, irregular connective tissue, adipose tissue, that's fat, of course, hair follicles, we're going to need nerves too, as well as oil-secreting and sweat-secreting glands. I'll talk about them more in detail in a minute. This one here, I don't think you've probably ever heard of. This is the Pacinian corpuscle. Pacinian corpuscles are very sensitive to pressure. So if you've been sitting one place too long and you kind of feel that discomfort, or somebody grab onto you tightly and you feel that constriction, compression, the Pacinian corpuscles are the ones that are functioning. All right. Sorry, one second, please. All right, sorry about that. Now, your skin color. We already spoke about melanin, but there are other colorants to your skin, okay? In addition to melanin, which of course is the most important one, don't get me wrong, you also have keratin and hemoglobin, okay? Keratin and hemoglobin. Now, melanin, we spoke about it already. It's produced by melanocytes. It's there to block UV radiation. The more of it you have, as you know, the more resistant you are to the effects of UV radiation. Everybody knows that. Now, that said, if you produce no melanin, the gene for melanin production is damaged, you end up with a condition called albinism. All right? And I'm sure you've all seen albinos before. Now, I'm hoping that you would have noticed some characteristics about albinos, aside from the skin color, that make them different. For example, you should have noticed that albinos are not necessarily white. Their skins can have a yellowish tinge to them, all right? Or in some cases, even a slight pink tinge to them. Secondly, their hair tends to have sort of a yellowish color, sort of like a blonde, as we say, right? Also, if you're paying particular attention, you'll notice that their eyes are not standard colors. If you're paying attention, you'd notice that their eyes are kind of pink, right? Now, why is that? Okay, you know melanin already in the skin is a brown pigment. The more of it you have, the darker your skin is. Hence, if you're an albino, no melanin in the skin, you look very, very light. Fair enough. Hair, melanin is what colors your hair as well. All right? So most of the color of your hair comes from melanin. And that melanin, of course, if you're not making any, your hair will of course want to default to a white color. But there are other pigments like carotene, which have a kind of a yellow color, which will be absorbed by your hair. See that? So their hair looks sort of yellowish instead of being white. Okay. The eyes, the iris has melanin in there. That's what gives your eyes their color. Okay. So without melanin, when you look at a person's iris, what you're basically seeing are the capillaries in the iris. And the capillaries, of course, carry blood. And of course, blood looks kind of red. So if you spread out this red color a bit, you end up with a pink look. So when you look in the eyes of an albino, the eyes will look pink because you're actually seeing their capillaries, right? And not their iris properly. All right. Hopefully that makes sense to you, right? Then now we have freckles. Freckles are caused by sun damage, usually sun anyway. So the skin gets damaged. Some parts are damaged more than others. And because of that, melanin is put into those patches at a greater rate than in other patches. So you'll end up now with tiny patches on the skin that we call freckles, okay? But freckles are normally a sign that your skin has sustained damage. Some people think they're cute, but at the end of the day, it is skin damage you're seeing, right? Then now, suntan. And yes, Black people can still tan. I mean, think about it. Most of you have been to the beach before and spent too much time out in the sun. I end up with stripping skin, right? Or even if you didn't get to that point, you notice that after you come over from the beach, you're a little darker for a few days than you were before, right? That darkening of your skin is still a tan. So even Black people can tan, all right? Or if you ever noticed that if you stay out of the sun for a few weeks, your skin lightens. That's like a reverse tan, right? The idea here, of course, is that the amount of melanin that your skin adds or subtracts from the skin is based on the amount of UV radiation you're being exposed to. The more UV radiation you're getting from the environment, the more damage your skin is going to get. And as your skin gets damaged, it tries to protect itself by producing all of this melanin, which makes your skin get darker. Obviously, there's a limit to how dark your skin can get based on the activity levels of the melanocytes, but it will get darker. And of course, if you're not exposed to UV radiation all the time, it takes a lot of resources to make melanin. So why would your body bother to make the melanin if you don't need it? So if you spend a lot of time indoors, your skin, of course, will start to lighten to some point, right? It's never going to go beyond that specific point that is based on the activity of your melanocytes, right? All right. So yes, you can tan, but in order to tan, you have to damage your skin first, then you make more melanin. Now, carotene. I'm hoping you pick up the fact that the carotene sounds like carrots, right? And this is kind of important because carotene is the same pigment you find in carrots that makes them kind of yellowish or orange, right? When you eat food containing carotene, like carrots, because that carotene is fat soluble, it can actually dissolve and enter the fat on the skin, right? And it gives that fat a yellowish color. And if your skin is light enough, it can actually transmit that yellowish hue to your skin. Okay? So for the most part, carotene is most visible in lighter skinned people. Now, some people say, oh, that's why the Chinese people can be called yellow people. There was this artist that was around when I was young called Yellow Man, who was an albino, funny enough. But once again, being an albino does not stop melanin from being deposited on their skin, right? So here, melanin, carotene, I should say, right? So remember, please, carotene colors the fat under the skin sort of a yellowish to orange color. If your skin is very light, that color shows through and gives you a yellowish hue, right? Then now we have hemoglobin. Oh, by the way, I should mention, if you increase the concentration of carotene in your diet to fundamentally extreme levels, you will actually end up dyeing your skin color. If you're light skin enough, your skin can literally go to orange. There are actually people who used to take carotene supplements so aggressively that they will have so much carotene deposited under the skin that they would actually turn orange, right? So they literally look like a carrot. I don't think people really do that much anymore, but you can still get supplements for carotene on Amazon or one of these places in case you want to try to turn yellow one day, right? Now, in addition to carotene, you also have hemoglobin. Hemoglobin, as I'm sure we all know, is the protein in blood that is going to be carrying oxygen, right? But when hemoglobin binds to oxygen, it gives it sort of a red pinkish color, right? Which of course shows through your red blood cells, which is why you call them red blood cells in the first place, right? Because of the hemoglobin bound to oxygen. If you have capillaries running through your skin with blood near the surface, it gives your skin a pinkish look to it, okay? Now, let me ask a question of the ladies. Or maybe the guy will know too. Why do you think women rub blush onto their faces when they put it on makeup? What is the purpose of that blush? Let me see if anybody's paying attention. Alexia, why y'all put makeup on your face and you put blush? Why are you doing that?
Sir, I don't know why
You
people
do it and you don't know why?
to create like to create a little color gradient.
Color gradient. You turn into a rainbow. Okay. All right. Robin, do you know why you put blush on your face?
Sir, I just put it on my face because it makes my cheeks look brighter.
Why are you making your cheeks look brighter is the question. Now, what purpose does it serve?
I don't know.
This is what I find. Most people use makeup have no idea why they're doing it. Let me explain the purpose of the blush and why it's kind of pointless. Highlighting the cheekbones is not the reason. It's simple. Young, healthy skin tends to have more blood flow to it, which means it usually has a slight pinkish look to it, right? That's one thing. Secondly, when women in particular, or men as well, are excited, sexually in particular, blood flow to the skin increases and makes their cheeks look even pinker. It's a sign of arousal, which of course means it is automatically a sign that is attracted to men. So a man looks at a female with fake arousal on her face, and of course, he's now more interested in that female. That's the reason, right? It's also the reason why it looks ridiculous on a dark-skinned person. Because you can't see blood through the skin like that. So if you're black as the ace of spades and your cheek then red, you're like, what the hell is going on? You look like a clown, right? So blush is not for everybody. If you don't believe me, you can check it out. That's the reason, right? But that's also the reason why you still have black women, instead of wearing a lot of the red blush, they wear like funny colors, like this weird silver one. And I don't know, I'm not really a makeup person. But a lot of the makeup, what you're doing with the makeup is that you're essentially trying to mimic signs of arousal, right? Which is why makeup is kind of sketchy. But we'll leave that alone. Now, erythema. Too much redness of the skin. Right? As it says here, caused by increased blood flow to the dermis from exercise or emotion. Once again, yes, like a rosal, but anger as well, and these kind of things can all cause erythema. So putting blush on your face, you're mimicking erythema. Okay? Now, we already mentioned albinism, but I want to mention vitiligo as well. In albinism, your body simply can't make melanin, which of course means no melanin, you tend to have the default color, which tends to be white. In vitiligo, on the other hand, over time, patches of skin lose the ability to produce the melanin, which means that a person with vitiligo will be born perfectly normal, look perfectly fine, and as they start growing, then the white patches will start to appear on their skin. In some cases, I mean, you have to understand that the extent of vitiligo will vary. I mean, sometimes you have a couple of tiny small white patches, and that's all you'll ever get. It wouldn't surprise me if some of you right now have some tiny white patches on your skin, right? But in some cases, the vitiligo can spread, right? And you end up with giant patches, sometimes so big that they interconnect. And it makes you look pitchy-patchy. That said, it's not physically dangerous to you, right? But it is, I mean, it's obvious it's going to be, it's not pretty. You know, people aren't supposed to be pitchy-patchy. So because of that, people with vitiligo are not really so keen on it. And so for example, what's his name? Michael Jackson, I said, had vitiligo. And that he took drugs that pretty much gave him the equivalent of albinism to bleach out the patches. If you want to believe that, you can go right ahead, right? Now, we mentioned freckles already. But freckles and moles can be formed when melanin becomes concentrated in local areas we mentioned already. This is normally associated with exposure to the sun, right? And it's normally a sign that your skin has been damaged. So freckles are bad. Freckles mean something bad happened to you. Now, a malignant melanoma. Once you say the word malignant, you know that's bad, right? So malignant things will spread. So a malignant melanoma is a skin cancer, right? It's normally associated, as it says, cancerous change in a mole that may metastasize and rapidly and is the most difficult to treat. So basically, you have a mole. Remember, the mole is basically a skin tag that is filled with melanin over time to prevent UV damage, but it can still get damaged and some of the cells can become cancerous. And once that happens, the mole starts to grow. And that is when it is now malignant. And as that mole grows, it can actually start capturing capillaries, start feeding itself blood. As it feeds itself blood, this cancerous lump can break off into pieces, and these pieces can actually enter your bloodstream, right? And once that happens, they can spread to all parts of the body. And you go from having skin cancer as a malignant melanoma to having lung cancer, to having cancer of the brain, right? And all sorts of other places. And that's what eventually kills you, right? So a melanoma by itself will not kill you. It's when it metastasizes, when it spreads from where it starts to all parts of your body. That is when, as we say, dog name your supper, right? The worst word you can hear as a cancer patient is metastasize, because it means the cancer is out of control. All right. So we mentioned carotene already. And we mentioned hemoglobin already, so we won't bother with that. Now, here are some ways in which your skin will respond to disease. Jaundice. Now, John, this is something that happens a lot in babies, right? And the severity of jaundice in a newborn is normally nothing to be too worried about, right? In adults, it's a serious problem, but in jaundice now, you have bilirubin is deposited under the skin because the liver is not properly functioning, right? Liver is supposed to break down bilirubin and then use it to make bile salts, called bile pigments, right? When the liver is not functioning properly, the bilirubin can be absorbed into the fat under the skin and color the skin. So the skin has sort of a yellowish green color, right? In a newborn baby, a lot of times the liver does not fully start functioning by the time before the baby is born. So by the time the baby is born, there is excess bilirubin in the baby, so that the baby's skin looks kind of yellowish. Okay? That said, most infants born with jaundice do not need medical intervention. Right? It is only recently in the last few decades that everything I'm to you, you want to give people pills for it. Because pills cost money. Right? Here is the best treatment for a baby with jaundice. You take them outside. Indirect exposure to the sun a few hours a day will actually increase the rate of function of the liver, and the liver will remove the excess bilirubin from the baby, and the jaundice will clear right up. Okay? Simple as that. Carry the baby outside. Go ahead, Alia.
So I had a godson that had jaundice and he died after like 4 days. But when he was there, they kept saying that it passed down from his father. So is it like hereditary or something?
Jaundice is not hereditary. If he died after 4 days, then that you're talking about is a genetic disorder. There was definitely something else going on. The jaundice was just a sign of an non-functional liver, right? There are genetic conditions that can cause you to be born with a severely incompetent liver, right? But they are fairly rare though. Rare enough that I don't want a DNA test one from the baby just to make sure. So I don't know. It sounds to me like okay, here's the thing. A certain percentage of newborns die within the first week. Okay? People don't really talk about it. But yeah, you have a lot of babies within the first week, first year in general, just die. Right? It's so common that there's a term for it called crib death. You know, the baby seems fine, seems fine, boom, wake up next morning, baby dead. Or sometimes, as you say, the baby is born sick and just dies, right? But yeah, it has nothing to do with jaundice. Jaundice would just have been one of the signs of it, right? Anyway, sorry to hear about that though, but it is what it is, right? Now, in an adult, when you see jaundice show up, it normally means that their liver has become diseased. So jaundice in an adult tends to be much more serious than jaundice in an infant, okay? Now, here is something that you might find interesting. Your generation, which is Generation Z, has had a spike in liver damage, believe it or not, over the last 5 years. So more Gen Zers are coming through with liver damage and jaundice than the millennials before you. Because many of the Gen Z people like yourselves are drinking to extreme excess. Ever go on TikTok or one of those things I see people like drink like a whole bottle of vodka one time? I mean, that's a thing that people do. for likes. I mean, I just don't understand that. When you do something like that, when you knock off an entire bottle of vodka, you put extreme stress on your liver, right? And you can only do that so often before your liver gets permanent damage. As a matter of fact, what I'm describing is basically called binge drinking. I'm sure you've heard of binge drinking. Right? You'll have people that don't touch a drop of alcohol the whole week and then drink a week's worth of alcohol one night. If you know somebody who does this, they are the ones that are in extreme danger of developing liver disease. Because if you're drinking consistently throughout the week, small levels, your body can manage the alcohol. It can get rid of the alcohol before it damages it, it gets damaged, right? But when you put in one giant volume of alcohol one time, your liver just can't manage. And as your liver is trying desperately to cure you of the poison, which is the alcohol, it gets damaged. And you do that often enough, you're going to get liver disease. You're going to get liver cancer. It's going to kill you, all right? So if you see anybody who's regularly binge drinking, you might want to talk to them if there's somebody that you care about, right? Anyway, it mentions that the skin may appear bronzed due to the deposition of melanin of a person with adrenal gland functionality problems. So when the adrenal glands start to go bad, the skin might start to get darker in patches, right? Due to excess melanin production. Now, sometimes, of course, you can get bruises, and of course, the bruises tend to look sort of reddish. This is due to blood from capillaries beneath the skin that have broken open and have dumped blood under the skin. Now, as these blood cells die and the hemoglobin breaks down in them, they start to look black. So that is why when somebody gets a bruise, the bruise looks red at first, but over a day or two, it starts turning kind of black or purple in some cases, right? So a purpling bruise, that's what causes it. The dying of the red blood cells beneath the skin. We'll also mention the overeating of keratin-rich foods that can cause your skin to turn yellow. As I said to you, plenty of tablets that will do that, right? All right. Now, your hair. Your hair is considered to be an accessory organ. And by accessory organ, I mean it is an adjunct to your integumentary system, right? It is directly associated with your integumentary system. But it is not doing a lot of the functions that your skin will do, okay? But it helps. So, primary functions of hair. One, and this is the reason why people have not lost hair on their head. It helps to protect you from the sun. All right. See, this makes sense too. Human beings are one of the few animals on the planet that have this amazing evolutionary advantage called sweat glands, right? You might not think it's amazing, but most animals do not have sweat glands, right? For example, your dogs don't have sweat glands. Your cat doesn't have sweat glands. Pigs and chickens, they don't have sweat glands. None of them can sweat. Sweat helps you to cool your body, right? It helps to control excess heat. Now, once human being started losing the hair, okay? Remember I said to you, you lose the hair, so you lack that protection against UV radiation. So what happens? You get melanin, your skin gets darker to help to protect you against that UV radiation. All right? Now, the hair on your skin sweats, which helps to cool you, right? Now, the hair on your scalp also sweats. Hear me, the hair sweats. The skin on your scalp sweats. So why do you have hair there? It makes no sense. You obviously don't need it that much because you got sweat glands all over the body and you don't have a lot of hair on the rest of your body for the most part. So why have it to your head? All right, see if this makes sense to you. The hair on your head is loaded with melanin. When you're exposed to the sun, the UV radiation is absorbed by the hair on the top of your head. So it reduces the amount of UV damage that you can do to the skin on the top of your head. It also means that less UV damage, less heating of your head can be done as well. Okay? Because your hair is actually absorbing UV as well as heat. If you don't believe me, shave your head and go walk out in the sun. It is an incredibly unpleasant experience when you can feel the sun beating down on the top of your head. It feels like you're being boiled like an egg. Okay? When you have hair, it's not great, but it's not that bad. So that is why you still have hair on your head. Helps to protect you from the sun. If you think about it, you are a bipedal organism. You walk upright, which of course means your head of all the parts of your body is the most exposed to the sun. So that's why you have hair. It's not so you can braid it and make it look pretty. It's to protect you against the sun. Right? But not only that, hair can also protect you against the cold. Right? And this is one of the reasons why there's a significant difference between the hair of people who evolved in a very cold place versus a very hot place. So let's take your standard sub-Saharan African person. The hair on their heads, or our heads, I guess, is going to be tightly curled, right? And packed together. This allows you to absorb the sunlight, of course, right? But also to create a layer of warm air near the surface of the skin and help to hold it there. Not hot air, no, warm air. The idea here is that this air layer acts as insulation, right? So it makes it harder for your head to warm up. And it also, of course, because there's spaces there, because if you're an African person, you have fewer hairs on your head than a non-African person, right? So it allows circulation of that air around your scalp as well, right? So when your head is very, very hot, you just move around and you can feel as the breeze going over through you, passing over your head, and feel your head cooling down much more easily. Now let's contrast that with let's say a Caucasian person or an Asian person that have straight hair that lies flat on the skull. That straight hair is great at retaining heat. It acts as a blanket over their head. And because of that, it absorbs heat like crazy. So in a cold place, having straight long hair is beneficial. It helps to keep your brain warm. If you're in a hot place, there's absolutely no benefit to it because it's actually going to overheat your brain. So if you think about it, any hairstyle in Jamaica that involves long straight hair is stupid. Right? Having long straight hair in Jamaica is stupid. It's simply going to overheat your skull for no reason. The braids are not so bad. Because even though you're braiding, you're leaving channels running down through your head where you can have exchange of heat with the environment. So you have bare patches in the scalp, right? Anyway, hopefully that makes sense to you why some hair can be straight. It's an advantage in a cold place. When the hair is curly, it's an advantage in a hot place, right? Now, eyebrows. Eyebrows are great at keeping sweat out of your eyes. Even the shape of the eyebrow is designed to wick sweat to the side of the head. Think about it. Your ancestors sweat to cool themselves, right? You think of your distant African ancestors running throughout the heat of the day, hunting, you know. Let me go back to sweat glands again real quick because sweat glands are so important to human beings. You wouldn't even believe it. Sweat glands allowed human beings to hunt animals that ordinarily human beings could not hunt. What is stopping them from hunting it? Let me explain. Most animals in Africa are most active towards the end of the day when the sun is going down or in the beginning of the day when the sun is going up, simply because it's cooler, right? Under those circumstances, you are competing with the animal at its best. Human beings are terrible animals. We're slow, we're weak, our senses are crap in comparison to the senses of other animals and the speed and strength of other animals, right? So there's no way a human being could compete one-to-one with another animal. But guess what? Because we evolved sweat glands, we don't hunt at the coolest parts of the day. Human beings hunt at the hottest possible part of the day. Why is that? See, this makes sense to you. A hunting group goes out, they come across a wildebeest or a zebra. You fling a spear, bam, you hit the wildebeest. He runs off. There's no way on God green earth you could ever catch that animal. It was too slow. You've wounded it, it has run away. It doesn't have no use to you. But guess what? The day is very, very hot. The wildebeest is running away with the spear sticking out of his side, going 30 miles an hour, right? Your ancestors are behind him, just jogging. Not even run fast, it's a jog, following a trail of blood. Animal quickly gets tired and it starts overeating as a stop and starts panting to cool itself. Looks behind it, there's your ancestors coming up again down the road, just jogging away like it's no big deal. They're sweating, they're keeping themselves cool, and them all right. They won't overheat. So the animal just runs off again and just keeps running. And as he's running and getting more and more tired, more and more overheated, the ancestors right behind him, just taking them stroll. And eventually the animal drops dead of heat stroke. And a few minutes later, here come your ancestors to collect the body. And because it's the very hottest part of the day, there are far fewer predators around for your ancestors to worry about having to fight over them kill. And so therefore, sweat glands, right, allowed us to evolve by helping to provide us with food. Anyway, I mentioned it now. It will come up again later, but I've already told the story, right? So you have eyelashes designed to wick away the sweat. The sweat designed to cool our bodies so that we can function better in the heat of the day. Your eyelashes. Eyelashes are designed so that when you squint, you can sift sand out of the air. So in the hot part of the day when the breeze will blow hot and kicking up the dust, you can keep dust out of your eyes. Your nose contains hair as well, which once again helps to filter out dust and particles out of the air, right? So all of these things help you to function in where we're evolved, in Africa, right? Now that I've said all the nice things about hair and sweat, let's talk about the basic structure of the hair. Your hair is looking at two basic parts. You have the shaft, you have the root, okay? The shaft now is the part that projects out of the skin. So when you touch your hair, you're touching the shaft, right? The root now is the part of the hair that runs through the dermis of the skin. I may go all the way down into the hypodermis. The root is comprised of a hair follicle, which surrounds the root itself. And that has two parts, an external root sheath and an internal root sheath. Then you also have the bulb of the root, which is found at the base of the follicle, right? And you have the papilla, which is found at the bulb. And the papilla contains blood vessels, capillaries, lymphatic vessels, things that are filled with nutrients that are needed for the hair to grow. Right? And in addition to that, you also have a matrix in the bulb. And the matrix is where you actually produce the hair from. So the papilla helps to nourish the hair while the matrix makes the hair, right? Here's your lovely diagram. Please make sure you can label this one if required to do so, right? Then now, as we mentioned to you before, the hair on the body is very thin. It's not really going to be warming anything, okay? So the hair on your body is not for warmth like other animals. It's sensation, right? The hair on your skin allows you to sense when things are touching you. Now, it mentions here that the shaft of the hair projects above the skin, you know that already, and that your hair is made up of keratin, hard keratin. And the hair has 3 layers. You have a medulla, which is the core, and by now you all used to medulla being in the core of things. You have the cortex, which surrounds the hair, and you have the cuticle, which look like scales that are overlapping on the surface of the hair. Yeah. So your hair, where is it? So your hair is shaft and root, right? But when you cut through the hair shaft and you look, there are 3 layers. Remember, medulla, cortex, cuticle. Then now, there are more than one type of hair, okay? You have what we call vellus hair. You know, like vellum. Vellus hair is found on your body. So they're fine, short hairs. You're born with these, right? And you have intermediate hairs because they get to a certain length and then they stop. And then you have terminal hair, which is going to be able to grow longer than intermediate hair, but it tends to be coarse, okay? So vellus hair, intermediate hair, and terminal hair, the 3 types of hair. Now, here's the thing. On average, assuming that you're a healthy person and you're moderately young, your hair grows at a rate of about 2 millimeters per week. 2 millimeters doesn't sound like a lot, right? But there's a reason why if you're a guy, you don't really need a haircut more than once every month or once every other month, depending on how you feel, right? Because the hair doesn't grow that long or that fast. And that is why, of course, when women cut their hair, it takes forever for the hair to grow back, right? 2 millimeters a week. Now, when the hair can be in the active phase or resting phase, right? When the hair is in the active phase, it is actually actively growing. It's getting longer and longer and longer, right? But it can slip into a resting phase, right? So basically the hair grows until it gets to its maximal length, then it stops. And from this point on, the hair no longer grows, it just sits there. Until eventually, the hair itself simply falls out, right? So the hair is shed, as it says. Now, as you get older, and what happens is that you end up with more hairs being shed and not being replaced. So your hair starts to thin. And I want you to understand that it is most prominent, most common in males, okay? That said, females can also have hair that thins. So don't think females can lose hair as well. So if your grandmother is still alive and you're around your grandmother, her hair is thinning. I'm sure if you look, you can see little patches of her scalp through the hair because it's thinning out. Okay. Now, of course, in males we lose hair faster than females. One of the reasons for it is actually testosterone. Believe it or not, baldness in males is strongly linked to testosterone levels. So very high testosterone levels actually poison the hair and cause the hairs to die or fall out. Right? Now, one of the best predictors of whether or not a male will lose a significant amount of hair is, does your father have hair? Right? So, Jidan, if your father still has hair, you'll probably be okay. Right? But if you started to thin out a lot, well, you know where it go, right? So generally speaking, if your father loses hair, you will as well, right? That is because of male pattern baldness. Male pattern baldness is genetic. So you basically inherit it from your father. Now, hair color. For the most part, hair color is determined by the amount of melanin you have in the hair. Even black hair is technically not black, is extremely dark brown. Because, of course, melanin is brown. So the greater the concentration of melanin you have in a particular area, the darker the area looks until we just call it black, right? But it is technically not black. It's just very, very dark brown. So, of course, the less melanin you have in your hair, the lighter brown your hair can be, all the way up until you have blonde hair, okay? That said, people with red or orange hair have a special type of melanin. And what makes this melanin special is that it's crap, right? People with red or orange hair, and I don't know if you've ever seen a black person with orange hair, it happens not that it's not that uncommon. They simply have inherited a bad type of melanin, okay? Here's what makes this melanin bad. This melanin does not properly absorb UV radiation. It doesn't do it very well. It does a poor job of it. And that's one of the reasons why when people with red hair or orange hair get exposed to the sun, instead of tanning, their skin tends to burn very easily. So if you think of like Irish, Scottish people, you know, they tend to have a very high concentration of people with red hair. And they're also very susceptible to the effects of the sun because their melanin is just terrible, right? So that's why you end up with somebody in Jamaica, for example, with orange hair, and their skin can even be kind of dark, and they still end up with skin cancer because of how awful their melanin is, because it is from the red melanin variety, okay? Now, what causes our hair to turn white? Some people believe that you can scare somebody. If somebody gets enough of a fright, their hair will just turn white overnight. I don't know if you've ever heard this. They don't be frightened the white out in here. Don't be frightened until the hair turn white. I'll go with that saying in Jamaica. Now, let me put this to rest. Your hair cannot turn white overnight because a duppy frighten you. First of all, there's no such thing as a duppy. Second of all, there's no mechanism to turn your hair white overnight. Why? In order for your hair turns white, for the same reason a polar bear has white hair. If you went up to a polar bear and plucked one of his hairs out and managed to get away without dying, and looked at that hair under a microscope, that hair is not white. A polar bear's hair is translucent. It's almost transparent, right? There's air trapped in those hair follicles, shaft. And the hair containing the air makes it a very good insulator. So the fur of a polar bear is very good at keeping it warm because of the air trapped in it. It looks white because as light passes through the keratin and hits the air layer, it gets refracted. And the refracted light comes back to your eyes, looking white, right? Now, that said, as you get older, you decrease the amount of melanin that is produced and put in the hair, and you end up with more and more air bubbles in the hair. And increasing the number of air bubbles in the hair does the same thing that the polar bear hair does. Light comes in, passes through the keratin layer, hits the air in the air bubble in the hair, and gets refracted out. Hence, it looks white. If you plucked a white hair from a person's beard and looked at it under the microscope, it is not white. Okay? They're simply translucent. It is refraction that makes it look white. Okay? That said, how long you keep your melanin colored hair, how long it takes before your hair starts to turn gray, is strongly influenced by your genetics. All right? As well as your diet. So if your mother still has a luscious head of black hair when she's 50, then you can expect the same for the most part. If your father is turning gray in his 40s, you can expect the same. Okay? For the most part. All right, so this, of course, is your hair structure. You should be able to label one of these if given. So I leave you to figure that out. Instead, I want to talk about hair growth cycle. There are 3 stages to the growth of a hair, right? As it says here, you have the growth stage that can last up to 3 years. You have the resting stage that can last between 1 and 2 years. And you have the stage at which you lose your hair. You're normally losing about 100 hairs a day. They just fall out, right? Now, have you ever heard this idea that if you're a woman and you brush your hair too hard, some of the hair will fall out? If you have, it is partially due to this idea of the resting stage. When the hair, when it's resting, is more susceptible to being yanked out than when it is growing. So if your hair is in a resting phase and you give it a good strong brush, you're going to get hairs coming out, right? Now, the 3 stages that we looked at can be broken down into these more scientific-looking stages. Anagen, catagen, and telogen, right? So anagen, the hair is growing. Catagen is a transitional phase. So it's going in catagen, you're going from anagen to the next stage, which is telogen, which is the resting phase. So this says that each hair passes through the phases independent of the neighboring hairs. So all hairs of your head are not going to go through the same stages at the same time, which is why you'll have hair falling out from all different parts of you instead of like in patches, right? So here is the information that is broken down in a little bit more detail here. As I said, approximately 85% of all hairs are in the anagen phase. So 85% of the hairs are actively growing, okay? And the anagen phase can vary from 2 years to 6 years, as it says. And it can give you a growth of up to as much as 10 centimeters per year. 10 centimeters, of course, as you know, is 100 millimeters per year. It is unlikely that anybody's hair will grow more than a meter long, right? So yes, you can grow hair. I mean, obviously, for Black people, it's a little bit more complicated because the hair doesn't lie flat. So you can end up with a giant afro, right? Or if you have straight hair, you can end up with hair that falls down just around the level of your lower back, right? And that's normal. It can grow to that length. It is very strange, it's very abnormal for your hair to get down to your ankles or those kind of lengths. Okay? It can happen, obviously, but there's a genetic component to that, right? Then now the ketogen phase. As it says, the hair enters into the ketogen phase, which lasts about a week or two. During that phase, the hair follicle is going to shrink to a sixth of its length, and the lower part breaks off. So the idea here is that in the anagen phase, the hair is growing, it's attached to the follicle all as well. Ketogen phase, the hair follicle starts to constrict until it breaks off. So the hair is now sitting there, but it's not directly connected now to the follicle. And the telogen phase lasts about 5 to 6 weeks. And during that time, the hair doesn't grow, it just sits there. Of course, unless you're brushing it out. But eventually, it will fall out, right? Around 10 to 15% of hairs are sitting in this stage at any given time. Once again, the sort of the distribution is more random, right? All right. Now let's talk about the glands that make up the hair, the skin. Now, hopefully, this is information you already have, okay? There are 3 main types of glands you'll find in your skin. We've mentioned them before, so it shouldn't come as any surprise to you. You have your sebaceous glands, and your sebaceous glands produce a substance called sebum, which contains lots of oil and other substances, right? Then you have your sudoriferous glands. And your sudoriferous glands are your sweat glands. And of course, as you know, sweat is mostly water. And the last type of gland you may have heard of is called the ceruminous gland. And the ceruminous gland produces this thing called cerumen. And cerumen is actually earwax. Okay? Wax in your ears, cerumen. Now, your sebaceous glands are connected to the hair follicle, right? But here's the thing. You're not going to have these sebaceous glands on your palms or the soles of your feet. I am hoping that you all have figured out why this is a very bad idea, okay? Imagine trying to climb a tree and your palms and your feet are slick with oil, right? That's an accident waiting to happen. So, of course, it makes sense that you will not have oily secretions on your palms or the soles of your feet. That said, you still have sweat glands on your palms, all right? Now, as it says here, sebum is an oily substance that prevents hair from drying out. It also coats the skin and helps to reduce evaporation, right? So sebum is good stuff. Keeps the skin soft and moist, and it can even help to control the growth of bacteria on the skin. So if your skin is overly dry, it's susceptible to bacterial infection. It tends to be hard as well. It's not soft and supple, which is one of the reasons why people using lotions and these kind of things to increase the softness and the suppleness of the skin if their skin is excessively dry, right? Like my skin, for example, right? Then we have sebaceous glands on the face become enlarged and you get infected, you can get blackheads. So the sebaceous gland on your skin can produce lots of oil, and dirt can block the gland. Since that gland it has a duct, right? So you can imagine, here's a duct here. So you can imagine dirt getting into this duct and blocking it up, preventing the oil from being secreted out into the hair canal which will then take it to the surface of the skin. And these sebaceous glands they're producing oil like crazy. Eventually, this causes the sebaceous gland to swell because it has all this oil in it. I know where for it to go. And if bacteria get into the oil, the bacteria can feed on the oil and oxidize the oil, helping to turn the oil black. Right? And that's how you get a blackhead. So remember, a blackhead equals a blocked sweat gland with oxidized oil in it, right? Now, pimples are a little different. Pimples are directly caused by a rampant bacterial infection. Oh, by the way, I should mention that the blackheads, the oxidizing of the oil, is not necessarily only by bacteria, right? They can oxidize on its own if it's exposed to the air, right? But of course, bacteria can also oxidize it. Pimples now is directly bacteria. So you have certain bacteria that feed on the sebum. And as you're feeding on the sebum, they can infect your sebaceous glands because, of course, that is the source of the sebum. So they replicate, they breed up in the sebaceous glands, and you end up now with your immune system attacking that sebaceous gland. And that is how you get the pus. So when you squeeze out a pimple, that creamy blob is plop out is a mixture of dead cells, dead skin cells, pus, which of course is a combination of red blood cells and tissue fluid, red blood cells, white blood cells, tissue fluid, and bacteria, and bits and pieces of cell, right? So that's that creamy stuff there. That's what it is. It's basically a battleground in which your white blood cells are killing off bacteria. Now your sweat glands. There are two types of sweat glands. You have your apocrine sweat glands and you have your eccrine sweat glands. The apocrine ones are the ones you find in your armpit and the pubic regions. So those are special sweat glands. Okay? Whereas your eccrine sweat glands are there primarily to produce your normal sweat. That's the stuff that cools down the body. Okay? Now, the whole of your skin, except as it mentions here for your nipples, contains sweat glands. Technically, your nipples are a sweat gland to begin with, but we won't get into that. And of course, your external genitalia in males, so you won't have sweat glands on the glands of the penis, for example, right? Now, obviously, the purpose of these sweat glands is to reduce. First of all, it reduces the temperature, right? But the sweat also helps to control bacteria on the surface of your skin, believe it or not. So sweating, some people are like, oh, people who sweat, they smell so bad, oh, well. But guess what? People who have healthy sweat tend not to get bacterial infections. So they might smell bad, though that the smell itself is also determined by a lot by cultural preferences. For example, your average African person does not use cologne or these things. So they prefer their natural body smell. So an average Jamaican person going on a bus in Kenya, for example, you wouldn't be able to manage. The smell coming off of the bus would blow your nostrils up, right? But for them, it's perfectly normal. They're used to it, right? And once again, because that is their normal body sweat, it helps to keep down bacteria. So as much as somebody might say, boy, they smell so bad, their skin is still healthy, right? Anyway, as I mentioned here, you're losing 500 cc's to a liter of water a day through your skin. So that's just sweating if it's hot, or ours is evaporation through the skin. And humans have the most efficient sweat glands, right? Now, sweat can be produced in response to several different things. Obviously, if you're hot, you're going to sweat, right? But I'm sure, I don't know, maybe you've never had a nervous sweat before, you know? You're sitting there minding your own business, something weird happens, you think you're in danger. All of a sudden, it's not burst out in what we call a cold sweat, right? That's a real thing. Then now, so also sometimes you'll have people who they're asked to perform or give speeches or whatever, and then under the arm starts sweating out hell, and their palms start sweating, That's also a nervous sweat, okay? But that is all eccrine sweat. Or we can also call it merocrine sweat as well, right? So that sweat there, that eccrine or merocrine sweat contains 99% water. So it is overwhelmingly water. Some amount of salt, not a lot. Some traces of urea, uric acid, these kind of things as well, which is one of the main factors that makes somebody's sweat smell bad. But all right, realistically, okay? Fresh sweat, the sweat that you just made, as it's just coming off of your body, has no smell. All right? So fresh sweat has no smell. Normally, when you smell somebody and they're very sweaty, you see you're so stinky, it's because the sweat has been on them for hours. Right? And bacteria have broken down the urea and the uric acid in the sweat to produce ammonia and other noxious chemicals. And that is what you're smelling, right? But fresh sweat shouldn't have a smell at all, right? Now, that is different from apocrine sweat, right? Remember, apocrine stuff is coming from under the arms, it's coming from the groinal region, right? So it's coming from the genitals. It also mentions around the anus. Now, why are you sweating differently under the arms and around the anus and in the genital regions? That sounds a bit weird. For the same reason why you see dogs sniffing each other's butts. The sweat being produced in these regions is filled with all sorts of proteins, lipoproteins, glycoproteins, right? Glycolipids, carbohydrates, lots of different chemicals, right? And these chemicals are actually information that our ancestors used to use when determining the health, sex, and other factors of someone of the opposite gender, or even the same gender. So when you see dogs smelling each other's butts, they're basically taking notes of what is going on with the dog, right? So they're examining the dog by smelling his butt, because it's giving off all information in those sweat glands around that area. Now, human beings have an absolutely terrible sense of smell. But it's obvious your ancestors did not. Why? Because we still have apocrine sweat glands and they still function. And because of the fact that the sweat being produced in these glands is so rich in nutrients, remember we're talking about proteins and glycoproteins and glycolipids, all of which are fuel for bacterial growth. This is the reason why the underarm sweat can tend to get very rank if you don't wash under your arm regularly, because the bacteria are breaking it down and releasing very noxious chemicals because of it, right? So the sweat on your skin probably won't smell that much, but the sweat under your arms and the groinal region, that is a different story entirely, right? Now, your cerebellous glands and your mammary glands are modified apocrine glands, right? The cerebellous glands, remember, produce earwax. And earwax is great for keeping your ears clean, for helping to prevent bugs from crawling into your ears because earwax smells bad, it tastes bad. Insects don't like it, they won't go into your ear canal for the most part, right? And mammary glands secrete, of course, milk. All right. I think we have burns further on this thing, will we? Yeah, we'll do burns later on because there's more information about burns later. About first degree, second degree, third degree burns. We'll talk about all of those later. Just be aware of the glands, okay? So here you have your apocrine sweat gland. If you notice here, it has a duct that opens up onto the hair shaft, right? Now, we mentioned what earwax does already, so we don't need to go through that again. And remember now, well, I'm sure you know this, but let's make sure. Earwax normally is supposed to line the inside of your ear canal, right? And it prevents or reduces water loss, and it prevents bacteria and insects and all sorts of other things from getting through to the skin within your eardrum or within your ear canal, right? Now, over time, in some people, it will build up until it actually forms big globs that can actually block the ear canal. And it can press on the tympanic membrane and cause pain, right? But normally, what is supposed to happen is that the earwax is supposed to dry up and flake off without causing a blockage. So most people will not suffer from very many blockages throughout their life, right? I mean, they can be bad enough that they can actually completely block hearing, and a person can think they're actually deaf because of all the earwax in their ears, right? That's the thing that actually does happen. All right. We have nails coming up. 7 o'clock. All right, let's stop here. We'll come back at 7:20 and we'll do nails. So 7:20 for nails.